In session 32 here, we're going to be addressing some of the different properties in algebra that you can use to help recognize and create equivalent expressions. Expressions are equivalent to each other if you have a situation in which all of the answers and solutions to one expression for all the variables that may occur in that expression are also the exact same solutions to the other equivalent expression as well. Okay, this is going to be a little bit lengthy. We have several different properties here that we're going to address in this particular session and lesson. The first one is the commutative property of addition. And what the commutative property says is that for any two numbers that exist, or that you choose, a and b, a plus b will equal the same thing as b plus a. What's the difference between these two? Well, the difference is the order in which you add things together. In this first one, you're starting with the a and you're adding b to it. On this side of the equation, you're starting with the b and you're then adding an a to it. Well, the commutative property says it doesn't matter which order you start with or that you write it in. You're still going to get the same answer in an addition problem. So that's your commutative property of addition. You also have an associative property of addition. And that says that for any three numbers, a, b, and c, parentheses, a plus b, parentheses, plus c will equal the same thing as a plus parentheses, b plus c, parentheses. Now, if you remember from earlier lessons, you always do what's in the parentheses first. So in this particular property here, it's saying if you have parentheses around the first two numbers that you're adding together, you have to add the a plus the b first and then get that answer and then add c to it. Well, it's telling you that that's going to give you the same answer as if you started with a and then added to it parentheses b plus c. So parentheses is what you have to do first. You would calculate b plus c and then you take it and add it to a. What they're telling you is it doesn't matter which way you group these, whether you do parentheses a plus b first or whether you do parentheses b plus c first and then add it to the other variable or the other number, you're going to get the same answer every time. Here's an illustration. A here represents 2, b represents 8, and c represents 4, or 4 represents c. So we have parentheses 2 plus 8 plus 4. Well, we have to do it's inside the parentheses first. On the right-hand side, we have 2 plus parentheses 8 plus 4. Our parentheses are around different numbers over here, but since all three are being added together, it doesn't matter which order we do this in or which set of two numbers we place the parentheses around. Let's go ahead and quickly just demonstrate this. What's 2 plus 8? That's what's in our parentheses. Well, that's 10. 10 plus 4 is 14. Come to this side. We have to do what's in parentheses first. 8 plus 4 would be 12. 12 plus 2 is 14. 14 does equal 14. Down here at the bottom, we actually have three different expressions that are all equivalent to each other. They don't look the same, but they are equivalent or equal to one another. Our first expression says 2 times parentheses 9 plus 3. Then our second one says 2 parentheses 3 plus 9. What's the difference between these two? Well, the difference between these two is that in parentheses we have 9 plus 3 here, but in this one we have parentheses 3 plus 9. And both of these are being multiplied by 2. So what's different here? What's different here is the order of which we are adding the numbers within the parentheses. And the order is what is affected by our commutative property. So the reason why these two expressions are equivalent to each other is by our commutative property. 9 plus 3 is going to give us the same thing as 3 plus 9, and that's what's inside our parentheses. The last one here is 18 plus 6. Can you see how we get that? We're going to use it with a different property that we're going to get to later. But if we went ahead and multiplied this out, 2 times 9 would be 18 and 2 plus 3 would be 6. We then take the 18 and 6 and add it together. We get the same answer as what we have over with these other two expressions. So this last one covers a property that we'll take a look at on our next screen called the distributive property. Before we get to those two distributive properties here, we're going to take a look at the commutative property for multiplication. On the first screen, we looked at the commutative property for addition as well as the associative property for addition. This time we're going to take a look at it for multiplication. And it works the same way as it does for addition. For any two numbers that you have, a and b, a times b is going to equal b times a. And an example of that, 11 times 7 equals 7 times 11. That's your commutative property of multiplication. You also have an associative property of multiplication. And what this property says is that for any three numbers that you have, a, b, and c, parentheses a times b, parentheses times c is going to equal the same thing as a times the parentheses b times c. And an example of that would be parentheses 9 times 2, parentheses times 2 equals 9 times parentheses 2 times 2. Well, what is 9 times 2? It's 18. 18 times 2 is 36. On the right hand side, what's 2 times 2? Because we have to do it in parentheses first. It's 4. 4 times 9 is 36. 36 on the right hand side does equal the 36 on the left hand side. So there's an example of your associative property of multiplication. Next, what we have here is the distributive property of multiplication when it's being used over addition and also when it's being used over subtraction. And what this property states is that for any three numbers that you have, a, b, and c, if you have a times parentheses b plus c, by distributing it through, you can take the a that's being multiplied and multiply it by each of the parts that are within the parentheses. So a times parentheses b plus c is the same thing as a times b, and since you have a plus here, plus a times c. So that would be your distributive property over addition. Over subtraction would be a times parentheses b minus c. And what you do here is you take your a times each of your parts. A times b would be ab, and a times a minus c would be a minus ac. And examples of that would be if you had 3 for addition, if you had 3 times parentheses 4 plus 5, that's the same thing as going 3 times 4 plus 3 times 5. That's what we have here. For our distributive property over subtraction, if we had 2 times parentheses 7 minus 2, that's the same thing as going 2 times 7 and then subtracting from that 2 times 2. And that's what we have over here, the distributive property over addition and subtraction. We also have the distributive property of division when used over addition and subtraction. And likewise, it says that for any three numbers that you have, a, b, and c, if you have b plus c and you're taking that and dividing it by a, that's the same thing as taking each of the parts and dividing it by a. So that would then be b over a plus c over a. So b plus c over a is the same thing as b over a plus c over a. You're dividing each of the parts by the a. So if we had a 6 plus 9 over 3, that would be the same thing as dividing 6 by 3, taking our plus sign, and then adding it to 9 divided by 3. And lastly, for subtraction, distributive property of division over subtraction, if we had b minus c over a, that's the same thing as taking each of these parts and dividing it by the a that's in our denominator. So we start off with b over a minus c over a. And that's how we come up with that property. And an example there, if we started off with 12 minus 8 over 4, the 12 representing the b, the minus 8 representing the minus c here over a, 12 minus 8 over 4, that's the same thing as dividing each of these parts in our numerator by 4. That would equal 12 over 4 minus the 8 over 4. So that's a lot in this particular session here that you need to learn. And you actually need to memorize these. Your commutative properties, your associative properties, and your distributive properties all need to be memorized. You'll be using those for quite a long period of time. Lastly, as far as your review goes, being able to recognize and create equivalent expressions is a very important skill in algebra. And the commutative property, associative property, and distributive properties can all be used to create equivalent expressions. Okay, that'll wrap up session 32.